Hello friends and welcome to this video. Myself NV Patil, Assistant Professor in Mechanical Engineering Department. I am going to explain you how to solve the maximization problem by using simplex method with the help of calculator. The learning objective of these videos are, after watching this video, you will be able to identify and set up a linear program in standard maximization form. You will be able to convert the inequality constraints into equations using the slack variables. You will be able to set up the initial simplex table. You will be able to find the optimal simplex table by performing the different pivoting operations. And you will be able to identify the optimal solution from the optimal simplex table. The statement of an optimization problem. Any optimization or a mathematical programming problem can be stated as we have to find the values of x which minimize or maximize the given function as a f of x, which is subjected to the number of constraints like gj of x is less than or equal to bj, where j values are from 1 to m, and another constraint is lj of x which is equal to bj, where again j values are from 1 to p. So these are the two constraints are given. Sometimes the constraints may be given as a greater than or equal to type. The values of x which we are going to find from x1 to xn are called as the design vector or decision variables, and the functions which we are minimize or maximize is called as the objective functions. And the constraints, when it is given as a greater than equal to or less than equal to, then the constraints are called as the inequality constraints. And when the constraints are given as a equality type, then it is called as a equality constraints. So such a types of problem when the constraints are given are called as a constraint optimization problem. While in some cases these constraints are not given. So such a problem is called as a unconstrained optimization problem. And here the values of x from 1 to n, then the constraints from 1 to m or 1 to p. So the n variable, m variable and p variable are not related with each other, they are maybe the different numbers. So we have to find the different number of values which is subjected to the different number of the constraint for the given function. Now let's see the standard form of a linear programming problem, that is LPP. Generally, the linear programming problem stated in standard form as we have to maximize the given function. The function may be containing the number of decision variables from x1 to xn. So we have to maximize f is equal to c1x1 plus c2x2 up to cn xn, which is subjected to this number of constraints, where the decision variables, that is x1, x2 up to xn, are greater than or equal to 0. That means it is a positive terms. And in this problem, the cj values, that is from c1 to cn, bj values from b1 to bm, and aij, that is a11, a12 up to a1n, are known as the constants. And the xj variable, that is from x1 to xn, are called as the decision variables or the design vectors, and which we have to find. Any LPP in its standard form is given as the objective function is of the maximization type, all the constraints are of the equality type, then the right hand side of each constraint is non-negative, that is 0 or positive, and all the decision variables are again non-negative. So in this form, the LPP problem is stated. So this is the standard form of LPP, and if the standard form is not given, then we have to convert the given problem into its standard form. That is, if the objective function is of minimization type, then it can be converted into a maximization by multiplying -1 to the both side. So you can see here this equation is of the minimization type, and by multiplying it to -1 on both sides, we can easily convert it into a maximization form. Now the second is that all the constraints are of the equality type, but in some cases the constraints are maybe less than or equal to type. Then we have to convert it into equality type, that is in form of the equation, by adding the non-negative slack variables. And generally the non-negative slack variables we are denoting by s. For first equation it will be denoted as s1, then for second constraint S2, and so on. So in this way, by adding the slack variables, we can easily convert these given constraints into a equality form. And sometimes the constraints are given as a greater than or equal to type. Then we have to subtract the non-negative surplus variable, which is denoted as again S, and for again first constraint we are denoting as a S1, second S2, and so on. So by subtracting this non-negative slack variable, we can easily convert this greater than equal to type constraints into a equality form. And sometimes the right hand side of the constraints are given as a negative, that is this B1 values are given as a negative. Then to convert it into positive, we have to again multiplying -1 onto the both sides. So it can be easily again get converted into positive form. And all the decision variables are non-negative, that is S1, S2 up to Sn values are non-negative. Now let's solve one numerical of the maximization type using the simplex method. We have given that we need to maximize the z, which is equal to 6x1 plus 4x2. So this is the objective function which is subjected to 2x1 plus 3x2 less than or equal to 100, and second constraint is 4x1 plus twice x2 is less than or equal to 120, where x1 and x2 are greater than or equal to 0, that is a non-negative. Now first we have to check that the given objective function is of maximization type or minimization. If it is minimization, then we have to convert it into maximization form. Here it is in the maximization form, so keep as it is. Then we have to check the right hand side values are non-negative. If it is negative, then we have to convert it into a positive form by multiplying both sides by -1. So here also the right hand side values are positive, so keep as it is. Then we have to check the constraints are of equality type or not. Now in this case the constraints are in equality form, so we have to convert it into equality form. So first we have to convert the given inequalities into equality form, that is in the form of equations. The first constraint and second constraint are both less than or equal to type. So we need to add the slack variables for the both constraints. So the first constraint become 2x1 plus 3x2 plus s1 is equal to 100. So here the slack variable is added. Now for second constraint, the second constraint becomes 4x1 plus 2x2 plus s2 is equal to 120. So here the second slack variable is added in the second constraint. And also we require that the decision variables are non-negative. So here the decision variables, as we are added the two slack variables, so x1, x2 and s1, s2 are the non-negative variables. So we can write it as a greater than or equal to 0. And due to the addition of the slack variables in the constraints, the objective function is going to be modified. So objective function can be written as z is equal to 6x1 plus 4x2 plus 0s1 plus 0s2. So here these slack variables again added in the objective function, and there is a no contribution of this slack variable in the objective function, so that's why its coefficient is written as a 0. Now next we have to prepare the simplex table. So the simplex table is prepared in this form. So first row is the Cj row, that is the objective row, and then we have to prepare the number of columns. So first column is for objective column denoted by CB, then second column is for basic variable, then there are the number of columns. So as per the variables present in the objective functions, we have to prepare these columns. So here there are four variables, so we have to prepare the four columns. Then next column is for solution column, that is the right hand side values, and then the next column is for ratio. Then the rows are depending upon the number of constraints. So as there are two number of constraints, so we have to prepare the two rows. Then the next row is for Zj, which is equal to summation of Cb into Aij. So for getting here the values, we have to take Cb into corresponding column values. And then next row is for Zj minus Cj row. Zj minus Cj row is used to check the optimal solution is reached or not. If In Zj minus Cj row, any value containing the negative elements, then the optimal solution is not reached. And if it containing all values are 0 or greater than 0, that is the positive values, then our optimal solution is reached. So now we have to write the different values in this table. So let's write the values in the table. So in objective row, that is in Cj row, we have to write the coefficient of this different variable which present in the objective function. So x1 coefficient is 6, so we have to write here 6. x2 coefficient is 4, so we have to write here 4 value. s1 and s2 coefficient are 0 in the objective function, so we have to write 0 for s1 and s2. Now next, in basic variable columns, the slack variables is called as the basic variables and the x1 and x2 are the non-basic variables. So in basic variable column, initially we have to write s1 and s2 and its coefficient in the objective function is written in the objective column. So s1 and s2 coefficient are 0. So we have to write in objective column. Now in first row, we have to consider the first constraint and the coefficient of the x1, x2, s1 and s2 in the first constraint is written in this first row. So the x1 coefficient is 2, so we are writing here the 2 value. x2 coefficient is 3, so we need to write here 3. s1 coefficient is 1 and there is no s2, so its coefficient is 0, so we have to write here 0. And in solution column we have to write the right hand side values, that is 100. Now for second row, so we have to consider this second constraints and its coefficient is written in the second row. So the x1 coefficient is 4, so we are going to write here 4. x2 coefficient is 2, then there is no s1, so write it as a 0 and s2 coefficient is 1. Now similarly, in solution column we have to write this right hand side values, that is a 120. So in this way we will be get the different values of the table. Now we have to find the Z0. The Z0 is summation of CB into Aij. So to get the element for the first column, we have to take 0 into 2 plus 0 into 4. For second column, 0 into 3 plus 0 into 2. Now for next, 0 into 1 plus 0 into 0, and for next 0 into 0 plus 0 into 1. So in this way we can obtain the Z0, and by solving we will be get all the elements are 0, because initially the s1 and s2 coefficient are 0 in the objective column. So initially we will be get all these values are 0. Now find the Zj minus Cj row. We have to take 0 minus 6, will be get as a minus 6. Then 0 minus 4 will be get minus 4. 0 minus 0, 0. Again 0 minus 0, 0. Now we have to check the optimal solution is reached or not. As this row is containing the negative element, so the optimal solution is not reached. So to get the optimal solution, first we have to find the key column. And the key column is the one which containing the maximum negative element. So maximum negative element is minus 6. So this will be called as a key column or the pivot column. Now we have to find the key row. So to find the key row, first we have to find this ratio. The ratio is calculated as BI divided by AIS. The BI means the solution column, that is the right hand side value, divided by the element present in that key column. So for this first ratio will be get as 100 by 2, and for this second will be get as 120 by 4. By solving, we'll be get 100 by 2 as a 50 and 120 by 4 as a 30. The key ratio is the one which containing the minimum positive ratio. So minimum positive is 30. So this is called as the key row, which is also called as a pivot row. And the element which intersecting in this key row and key column is called as the pivot element. So in this case 4 is the pivot element. So it is also called as the key element. Now in next table we have to convert this pivot element as a 1 and this remaining element in the key column as a 0. So to convert this we have to divide key row by the pivot element, and similarly by applying the row transformation this remaining element is get converted into a 0. And also for the next table, the basic variable which present in the key row, it is going to be leave the table. So it will be called as a leaving variable or outgoing variable. And the variable which present in this key column is going to be enter. So it is called as a incoming variable or the entering variable. So let's prepare the next table. So this is the table we already got. Now for next table, the Cj row will be as it is. The basic variable S1 and its coefficient is as it is because it is not present in the key row. So S2 variable is present in this key row, so it is going to be leave, and the X1 variable which is present in the key column is going to be enter. So in basic variable, in second row we have to write X1 and its coefficient as a 6, so we have to write here in objective column as a 6. Now we have to convert this pivot element as a 1. So we have to apply the row transformation. So for row transformation, first row we are going to define by as a R1 and second row we are going to be defined as a R2. Now to convert this pivot element as a 1, we have to divide this R2 row by the pivot element, that is a 4. So we can write R2 is equal to R2 by 4. And to convert this remaining element in the key column as a 0, we have to apply the row transformation as R1 is equal to R1 minus 2 divided by 4 into R2. And to use the calculator, this row 1 is going to be defined as a and R2 is we are going to be defined as a B. So in calculator, this is true transformation we can be denoted as B by 4, and for second a minus 2 by 4 into b. So R1 will be replaced by a and R2 will be replaced by b. So let's open the calculator. Now in this calculator we are going to define this two row transformation. So first we have to write for this row 1. So row 1, it is defined as a R1 minus 2 by 4 into R2. So in calculator we are going to define it as a minus 2 by 4 b. So to write the notation as a, we have to press alpha a minus in bracket, then for 2 by 4, click on this icon. So write 2, to go to the downward direction, press this downward arrow, then press 4. Now press this right side arrow key and again complete the bracket and then write b, that is alpha b. So this first equation is defined. Now to define this equation for second row, we have to press first this colon sign. So press alpha colon and then b by 4. So press again alpha b, then divided by 4. So in this way, these two equations are defined in calculator, and to get the values, we have to press this calc C button. So it asks you to the A value. So A value we have to put as a 2. So press 2 equal to, and B value we have to put this value as a 4. So press 4 and equal to. So we get A value as a 0, and this value we have to write in this first row in first column. So we have to write here in first row the value as a 0. Now next we have to find this value. So again in calculator we have to press equal to sign. Then again we get b by 4 value as a 1. So this value we have to write here. So we will get 1 value. And again in calculator we have to press the equal to sign. So by pressing equal to sign, again it asks you a value. So now we have to press the a value as a 3. So put the a value as a 3, press equal to, and b value as a 2. So when there is a question mark, it means it asking the values of that variable. So now b value is a 2. So we have to enter 2 equal to. Now we'll be get a value as a 2, and by pressing again equal to, we'll be get b value as a 0.5. So these values we have to write here. So first value will be get as a 2 and second value b value will get as a 0.5. Now to get the next column values, again press equal to in calculator. Again it asks the a value. So a value is 1. Then press equal to and b value is 0. So again press equal to will be get A value as a 1 and B value as a 0. So these values we have to write in this next column. So 1 and 0. Now to get the next column values, again press equal to in calculator. So pressing equal to, we have to enter the A value as a 0 and B value as a 1. So pressing equal to will be get A value as a minus 0.5. Again press equal to get the B value as a 1 by 4, that is 0.25. So these values we have to write here. So minus 0.5 and 0.25. And to get the values in this solution column again we have to press equal to sign in calculator. And for A value we have to enter the value as 100. Then press again equal to, and B value we have to enter as a 120. So again press equal to, will be get A value as a 40, and again pressing equal to sign will be get B value as a 30. So these values we have to write in solution column as a 40 and 30. So in this way you can easily get the different values in calculator in very less time and very easily. Now again we have to obtain the Z0. So Z0 you can again easily calculate it using calculator, that is 0 into 0 plus 6 into 1. So we'll be get this value as a 6. Then second element value 0 into 2 plus 6 into 0.5 will be get as a 3. Then 0 into 1 plus 6 into 0 will be get as a 0. Then again 0 into minus 0.5 plus 6 into 0.25 will be get as a 1.5. And now to obtain the Zj minus C0, 6 minus 6, 0, 3 minus 4, minus 1, 0 minus 0, 0, 1.5 minus 0, 1.5. Now we have to check this Zj minus C0 containing all positive values or not. Now here we will be get one negative value, so basic feasible solution is not reached. So we have to find the key column and key row. So here minus 1 is the most negative value, so it will be called as a key column. And then we have to find the ratio to obtain the key row. So for ratio we have to take the solution column value divided by the element present in the key column. So for first row will be get 40 by 2, and for second row will be get as a 30 by 0.5. So by solving we will be obtain this value as a 20 and second value as a 60. So minimum positive value is a 20, so it will be called as the key row, and the element which intersecting in between key row and key column is called as a pivot element. So again, to obtain the feasible solution, we have to convert this pivot element as a 1 and the remaining element present in that key column as a 0 by applying the row transformations. So let's prepare again the another table. And for this next table, again the variable which present in that key row is going to be vanish, and the variable which present in the key column is going to be entered. So for first row, we have to write the basic variable as x2 and its coefficient in C0, that is in objective function, as a 4. So this value we have to write in this objective column. And now we have to convert this pivot element as a 1 and then other element in that column as a 0. So for that again we are denoting this first row as a R1 and second row as a R2. Now to get converted this pivot element as a 1, we can divide this row 1 by the pivot element, that is a 2. So we can write R1 is equal to R1 by 2, and making the other element as a 0. So we can write R2 is equal to R2 minus 0.5 divided by 2 into R1. And for calculator again we are denoting R1 as a and R2 as a B. So for calculator these two equations can be written as A by 2 and B minus 0.5 by 2 into A. Now again using the calculator, similarly you can obtain the different values in the table. So I have already calculated these values and obtained the values. So I will get 0, 1, then 1, 0, 0.5, minus 0.25, minus 0.25 and 0.375, and in solution column the values as 20 and 20. So to obtain these values, again I am going to explain you using the calculator. So let's open the calculator. In calculator, we have to define these two equations. So for row 1, we have to define the equation, that is a by 2. So press alpha a by 2. So divide by 2, then press this alpha and colon key. Then the second equation we are going to define. So press alpha b minus 0.5 by 2. So 0.5. Then press this downward arrow key 2. Then right side arrow key and A. So press alpha A. Now press this calc C button. So it asks you the A value. So A value, first we have to put A value as a 0 and B value as a 1. So A value 0, press equal to B value as a 1, press equal to, so we'll be get A value as a 0. So we have obtained the same value. Again pressing equal to sign, the B value as a 1. So we also obtain the same value. Again press equal to sign. Again for the next column values, A value will be 2. So press 2 equal to B value is 0.5. So press 0.5 and equal to. So we obtain the A value as a 1 and B value as a 0. So same values we have obtained. Again to get the next column values, again press this equal to sign. Now A value is 1 and B value is a 0. So by pressing equal to sign we will be get A value as a 0.5. Again pressing equal to sign we will be get B value as a minus 0.25. So same values we have obtained here also. To get the next column values, again press equal to sign. Now A value is minus 0.5. So don't forget to press this minus symbol 0.5. Then again press equal to and B value is 0.25. So 0.25. By pressing again equal to, will be get A value as a minus 0.25. Again press equal to sign to get the B value as a 0.375. So we obtain the same values. And to get the solution column values, again press equal to sign. A value is 40. So press 40 equal to and B value as a 30. So again press equal to. So we can obtain A value as a 20 and again pressing equal to sign the B value as a 20. So here we obtain the same value. So in this way you can use the calculator to obtain the different values. And if there are again the 3 rows are given, so same way you can use the calculator to obtain the values for the 3 rows also very easily. Now next we have to find the Z0. So for this Z0 we have to write 4 into 0 plus 6 into 1. So we get this value as a 6. For next column value 4 into 1 plus 6 into 0 will be get as a 4. Next value 4 into 0.5 plus 6 into minus 0.25 will be get as a 0.5. For next value 4 into minus 0.25 plus 6 into 0.375 will be get as a 1.25. Now Zj minus C0, 6 minus 6, 0, 4 minus 4, 0, 0.5 minus 0, 0.5, 1.25 minus 0, 1.25. So now if we check the Zj minus C0 containing all the positive elements. So it is 0 or greater than 0. So our optimal solution is reached. And to get the solution, we have to write these solution column values for corresponding variable. So we'll be get x1 as a 20 and x2 value as a 20. And by putting these values in the given objective function, we can get 6 into 20 plus 4 into 20 will be obtained as a 200. So the solution for this given objective function, that is the maximum value of z, is 200 at x1 is equal to 20 and x2 is equal to 20. So in this way you can find the solution for any given optimization problem with the help of calculator very easily. So if you having any queries or difficulties, you can write it in the comment box. So I hope you enjoy the video and you like the trick of the calculator for getting the solution very easily. Thank you for watching. Have a nice day.